Hello and welcome to this lesson on halogenoalkanes. And the first thing we'll do is we will define what a halogenoalkane is. And as the name suggests, we've got a combination of an alkane with a halogen. So alkanes, you remember, are just carbon hydrogens with single bonds, and halogens are the group 7 elements. So let's have a look at a few examples. So you could have dichloro. So here we've got two chlorines hanging off a carbon, and if we've only got one carbon, the other's hydrogen, then this would be dichloromethane. Dichloromethane would be one example. Let's have a look at a propane example. Propane is going to have 3 carbons. Let's draw 3 carbons, and let's draw an iodine on this one, for example. So we're going to have an iodine here, and let's make it just one iodine. So the rest are hydrogens, in which case we're going to name this one. So it doesn't matter whether you number your carbons from left to right or right to left. The middle carbon is carbon 2. So this is going to be 2-iodopropane. 2-iodopropane. That would be an example with iodine. Let's do a mixed example now. Let's do a mixed example with 2 carbons on it. Let's do 2-bromo, 1,1-dichloroethane. 2-bromo, 1,1-dichloroethane. So let's name this one carbon number 1 and this one carbon number 2. So that means we're going to have, if it's going to be 2-bromo, let's write our name down so we can draw it properly. 2-bromo, 1,1-dichloro, and we've got 2 carbons, so that's ethane. Okay, we've already drawn our numbered our carbons, and it's 2-bromo, so let's put our bromine on our second carbon. The other chlorines are on our first carbon, so we can just go ahead and put our hydrogens in here. And the di suggests we've got two chlorines, and the 1,1 suggests that they're both on carbon number 1. So let's put a chlorine here and a chlorine here, and that leaves that one for a hydrogen. And there we have it. And the reason we're studying halogenoalkanes here briefly is that they're very useful in organic chemistry in the synthesis of other molecules, because of the bond polarity that we're going to deal with now. Because of that bond polarity, you can join the alkane bit of the molecule to another molecule quite easily in a chemical reaction. And so they're very useful in organic synthesis of lots of different complex molecules. And in order for that to happen, we need to understand the polarity, which is given by this diagram at the bottom of the slide, which we're going to do more on the next slide. Yeah, so polarity of the halogenoalkanes. And what we're talking about is that we're talking about the bond between the carbon and the halogen. And so that could be a carbon fluorine bond, it could be a carbon chlorine bond, it could be a carbon bromine bond, or of course a carbon iodine bond. And as you know, the covalent bond is a sharing of a pair of electrons, and a polar bond happens when that pair of electrons in the covalent bond is not shared equally. One of the atoms in the bond has an unequal share, where in fact they end up both having the unequal share. And it's driven by the electronegativity of the atoms, or specifically the relative electronegativity of the atoms. So let's have a look at the electronegativity of all the atoms. Here we have a little table of the electronegativity according to Pauling's scale, and you can see that fluorine, chlorine and bromine are all more electronegative than the 2.5 reading that carbon has. whereas iodine has the same electronegativity. So these electrons are actually going to spend more of their time near the fluorine atom in carbon fluorine. They're going to get dragged in this direction towards the chlorine in the carbon chlorine bond. Same with bromine, but the carbon iodine bond is not going to be polar because the electronegativities are pretty much the same. So these are the polar bonds. And if fluorine, chlorine and bromine grab more than their share of that electron density, electrons being negative of course, then the halogen becomes delta negative. So it's not a whole negative as in an ionic bond, but it's a partial negative, and that Greek D there is for partial. And so if the halogen has a partial negative charge, that must mean that the associated carbon has a partial positive charge. And that's what happens. You get a partial positive charge. So that partial positive charge on the carbon is important because if there were a negative thing, let's say call it a negative particle, floating nearby, then it would be attracted to that positive charge on the carbon atom, right? And these negative things we're going to call nucleophiles. Nucleophiles. And just breaking that word down a little bit, the phile bit is meaning attraction. So it's something that's going to be attracted to something else. And what the negative thing is going to be attracted to is a nucleus. And that's where the nucleo part of the word comes from. So a nucleophile is a particle that is attracted to nuclei, because nuclei are positive because they've got loads of protons in them. And examples would be, we're going to look at 3 examples. First one being a cyanide ion. So let's draw a cyanide ion up here. So cyanide is a carbon, nitrogen, 1- ion, and the carbon also has a lone pair that is what attacks the carbon. Another example would be ammonia. Ammonia is NH3. You remember this is not an ion. So let's just clarify that that is an ion. The cyanide is an ion, but ammonia is a molecule. But the nitrogen in ammonia does have a lone pair. It does have a lone pair, and that is what is very negative and is attracted to the positive carbon in the carbon halogen bond. And the third one we're going to look at is the hydroxide ion. So hydroxide. So hydroxide again is OH, and you remember that's got a minus charge in it as well. But as well as the minus charge, it has the oxygen has a lone pair. So we draw the lone pair like that. And that lone pair is what is attracted to the delta positive carbon atom. And so the next step will be to study the reaction mechanism, because what we can do is get a substitution of the halogen with the nucleophile, and that's quite useful. So that's what we'll study in the next lesson. But so far I hope this has been clear for you.